Alright, on this video I'm doing the last 3 theorems for this unit. And so the first one that I'm doing is called the equilateral triangle theorem. This theorem says that if a triangle is equilateral, then it is also equiangular. The way that I word it here is a triangle is equilateral if and only if it's equiangular. So this wording here goes back to the last unit when we were learning about conditional statements, converse, and all that. So this just means that it doesn't matter which way I say it, I can say it backwards. The theorem remains true. The statement remains true. So I'm going to show you that with these first 2 examples. So in this one, they're asking me to find the value of x, and on the picture they are showing me that the 3 sides are equal. They're showing me this by having lines on each of those sides. That tells me that the sides are equal. So they're showing me the triangle is equilateral. So by this theorem I can assume that it's also equiangular, which means that each of those angles are equal and they're each 60. So angle D is 60, angle E is 60, and angle F is 60. They're asking me to find the measurement or the value of x, I'm sorry. So angle F is represented by 6x. And since I know that each of those angles is 60, I'm going to put it equal to 60. And so to find the value of x, all I have to do is divide both sides by 6. And I get 10. 60 divided by 6 is 10. So this was like the conditional statement. If it's equilateral, then it's equiangular. So example 2, I'm going to do the converse. They're showing me that the angles are equal. So if it's equiangular, then it's also equilateral. So I can draw the little lines to show that the sides are equal. And so now, since I know those 2 are equal, I'm going to use them for my equation. 6x minus 5 equals 5x. And so I could do it this way, minus 5x on both sides. That's 0 because I canceled. And then I get rid of the 5 by adding it to both sides. And so I get x equals 5. Okay, so that's equilateral triangle theorem. If it's equilateral, it's equiangular. Same thing with the isosceles triangle theorem. So in this theorem, says if 2 sides of a triangle are congruent, then the 2 angles opposite those sides are also congruent. Again, I worded it with if and only if. So it doesn't matter which way I say it, it's true. So on the first one, they're showing me that 2 sides are equal. That means that the 2 angles opposite from them are also equal. So this angle and this one, they're equal. It says find angle ABC. So measurement of angle ABC is 60 because I know that those 2 are equal. I don't really have to do any work, I just have to know the theorem. This one, they're showing it backwards now. Now they're showing me that 2 angles are equal. So I'm supposed to know that 2 sides are equal. So the sides opposite from those angles are equal. Those 2 sides are equal, so I'll put them equal to each other. And then I solve this equation. So I'm going to do minus 3x both sides. Minus 4 on both sides. And then I have to get rid of the negative by divide. So x equals positive 14. Okay, and then the last theorem is called the third angles theorem, or third angle theorem. This one says if two triangles have two pairs of congruent angles, then the third pair of angles is also congruent. So, an example one, I'm just going to use it to explain what the theorem is saying. So it says if two triangles have pairs of congruent angles, so it shows right here angle A is congruent to angle D because they each have a mark showing that they're equal. So I'm going to say also being shown that angle B is congruent to angle E because they each have two lines. So angle B is congruent to angle E. So since I have two pairs of congruent angles, then I can assume that the last pair is also going to be congruent. So here on the picture they're showing me with the three lines that they're congruent, but if they didn't show me that, I could still assume that because I already have two pairs that are equal. So angle C is congruent to angle F. So example 2, they're asking me to find the measurement of angle R. So here I know P is congruent to X, Q is congruent to Y because they have two lines. So that means the last pair of angles has to be equal. So this one, R, has to equal C. So I'm going to put them equal to each other. So now I have exponents, but I'm going to do the same thing that I do with my other equations. So I need to get the x's on one side only. So I'm going to subtract the 2x squared. From both sides. So 6 minus 2 gives me 4. And I have 16 left. So next thing I have to do here is I have to get rid of the 4 first. So I do that by dividing. And I have x squared equals 16 divided by 4 is 4. I'm still not done because now for the last step I have to get rid of the exponent. So the opposite of the square is square root. So that cancels it out. And I gotta do it to both sides. So the square root of 4 is positive and negative 2. Anytime you take the square root of a number, you always have two answers. So my x value is positive and negative 2. I have two x values. And then they're asking me to find measurement of angle R, which angle R is this one here. So I'm just going to plug it in. So instead of x, I put the 2 and square. So you could type this in your calculator. If you do it without a calculator, you have to make sure that first you do the exponent. So first you would do 2 squared, which is 2 times 2. That gives me 4. And then times the 6. So that's 24. Measurement of angle R is 24 degrees. And that's your final answer.